Okay, so today we're talking about angle of elevation and depression. The angle of elevation is the angle formed by a horizontal line and the line of sight to an object. So you see, if you think about like you have from the bird looking across, straight across, that's the horizontal, and then the line of sight, what they're looking up to. That is called the angle of elevation. Okay, that's the angle of elevation. So then the angle of depression is, let's look right below it for the words. The angle of depression is the angle formed by a horizontal line and the line of sight to an object down. So like if the sun, just pretend the sun can look straight across from the sun and looking down to the object on the ground or to an object farther down, this right here, that's the angle of depression. Okay, now those two angles are also alternate interior angles, so the angle of depression is going to be equal to the angle of elevation. All right, so let's look at our foldable. So inside the first flap about angle of elevation. Okay, so it says that when looking up to an object, the angle of elevation is formed by an observer's line of sight. So they're looking up, so the line of sight looking up like the dinosaur is, and a horizontal line. So the horizontal line goes straight across, parallel to the ground. Okay, so a dog is standing 5 feet from the base of a tree. All right, so we have a tree. And I'm not going to try to draw a dog, so we have a dog like standing right here. Okay, so the dog is 5 feet away from the base of the tree, so let's put a 5 there. And then there is a cat up in this tree, so let's pretend it's right up here. And it's 16 feet up the tree. So this distance right here is 16. What is the angle of elevation from the point that the dog is standing on the ground to the cat in the tree? So the angle of elevation is from the dog looking up and made with the sight line from him looking up and the horizontal distance. So if you look at this, angle D, we have 16 as opposite and 5 is adjacent. So that tells me we're going to use tangent of D equals 16 over 5. All right, so now to get D by itself, we're going to have to do inverse tangent. And so when we type that in our calculator, the measure of angle D is 72.65 degrees, or 72.7 degrees. Okay, let's try another one. The angle of elevation from a soccer ball to the ground, to the top of the goal is 34 degrees. Okay, so like we have a soccer ball down here. It's on top of a goal. So this angle of elevation is 34 degrees. The goal is 8 feet tall, so that's the height of the goal. So what is the distance from the ball to the goal? That's down here. So that's another tangent problem. So you have tangent of, let's see here, 34 degrees equals opposite over adjacent. Okay, so tangent of 34 degrees equals 8 over x. So to get the x by itself, first you have to multiply. So you have x times tangent 34 equals 8. So now once again, to get x by itself, we need to divide by tangent 34. So we've done lots of these. It's just doing them in word problems using the terms angle of elevation. So you type this in your calculator and you get 11.86 feet. Okay, let's do a couple on angle of depression real quick. So the angle of depression is formed by the observer's line of sight. So they're looking down at something. Depression means down. Line of sight and a horizontal line. And you guys, I'll tell you, I think of my angle of depression and elevation as a capital Z. So here's your angle of depression and here's your angle of elevation. So that's kind of how I remember it. So the angle of depression is congruent to the angle of elevation because they are alternate interior angles. Okay, let's see if we can draw this one out. The angle of depression from an eagle sitting on top of a flagpole. Okay, so like we have a flagpole. So the eagle's sitting on top of it, and so they're looking down. So the eagle's like right up here. I'm going to call this E for eagle. So sitting on top of a flagpole to the base of a tree. So over here They're looking down at the base of a tree. Here's the base of the tree. All right, is 63 degrees. So that's the angle of depression. So I like to draw the horizontal right here. So this is the angle of depression. The biggest mistake people make is by putting it down here with the line of sight and the flagpole. But remember, if it helps, a capital Z, you're like, oh wait, that's the angle of depression. So that's 63 degrees. The flagpole is 18 feet tall. Okay, so there's several ways we can do this. What I'm going to do is I'm going to sit here and say, wait, if that triangle right there made up by the angle of depression, if the flagpole is 18 feet tall, then this side of the triangle is also 18 feet tall. So kind of draw it separately so you can really see it nicely. Is this would be 18, this would be 63, and what we're looking for is the distance between the pole and the tree. That's this distance right here. So this distance at the bottom from the pole to the tree would be the same thing as the distance at the top. So I'm going to call this X. So another way you could do this, just to kind of show you real quick, is you could sit here and say, all right, well, if the angle of depression is 63 degrees, then this angle is 63 degrees. The flagpole is 18, and that's X. You're still going to use the same information. It's just kind of a different way of looking at it, knowing that the angle of elevation and the angle of depression are equal. All right, cool. So let's go with our original triangle over here. So from 63, 18 is opposite, X is adjacent, so that tells me we're doing tangent. We don't always do tangent on word problems, but we use it a lot. I'd say more than the other two. All right, so tangent of 63 equals 18 over X. So once again, to get X by itself, multiply by X, it's going to cancel out. So you get X tangent 63 equals 18. So now to get X by itself, once again, divide by the tangent of 63 on both sides and type that into our calculator. So 18 divided by tangent of 63 is 9.17 feet, or 9.2 feet. Okay, one more. A shark is swimming at 28 feet below sea level. So like you have your sea level right here, and so your shark is 28 feet down. I'm going to put S for shark. We'll just write it out. I cannot draw a shark. Okay, if the angle of depression from a boat, okay, the boat's over here, and the angle of depression, its line of sight down to the shark is right there, and the horizontal line is the water, so that's its angle of depression, and it is 19 degrees. Then what is the horizontal distance between the boat and the shark? The horizontal distance is like your distance straight across from the boat to where the shark would be just underneath. That's the horizontal distance. So I'm going to put H for horizontal. So looking at this, once again, I have tangent of 19 degrees equals 28 over H. By now, we should be really good at knowing how to get the variable by itself when it's on the bottom of a fraction. We've been practicing this. So we divide by tan 19. All right, and I end up with 81.32 feet. So they're 81.32 feet apart horizontally.